Hello, I'm Phil Stirpe, Principal Technologist with QA. Today I'm joined by Troy Hunt, Microsoft MVP and author of the OWASP Top 10 for .NET developers. Troy, thank you very much for joining us today.
Yeah, hi Phil, thanks very much. Nice to be here.
Troy, you've just finished writing a course for QA to do with the OWASP Top 10. Who or what are OWASP?
So OWASP is the Open Web Application Security Project. They are a not-for-profit organisation and they produce a variety of different material for software developers in order to help them build more secure applications. And one of those pieces of material they produce is a publication called the OWASP Top 10, and it's the top 10 web application security risks, which go through and explain the 10 most common risks which we see in websites. And OWASP then does a very good job of explaining what the risk is, what the typical mitigations are, and they do all of this in a very technology agnostic way as well. So it's a set of guidelines that we can apply to ASP.NET, PHP, whatever you're working in.
Okay, thanks for that. Well, we'll come to the top 10 in a moment and look at how we can mitigate against them. But can I ask you first of all, where are these attacks actually coming from? Is it nation states? Is it disgruntled employees, mischievous hackers? Who is it?
Well, there are three main groups, Phil, that seem to be behind most of the attacks today. And the first out of those groups is professional criminals. So people that go out and hack websites, steal credit cards, install malware for the express purpose of financial gain. So this is a career for these guys. The second group is what we're coming to know as hacktivists, and we often know them as guys like Anonymous, lulzsec. They may have a cause or a greater good or a political driver behind their activity. They may be out just to have a little bit of fun. A lot of them do seem to be kids, literally legally kids, or very young adults who probably aren't fully aware of the ramifications of what they're doing and are just having a bit of fun. But be that as it may, they are effective. They do hit the news a lot. And the third group is the nation states. So this is governments that do have serious amounts of money behind them that are undertaking cyber warfare. So we've heard about things like Stuxnet, for example, taking Iranian nuclear centrifuges offline. It's a very, very serious way of doing warfare in the 21st century.
Wow. Well, with initiatives like OWASP and others, would you say that attacks are on the rise or dropping off?
I'm not sure there's much of a correlation between OWASP and the attacks at the moment. I mean, so certainly OWASP is a very good resource for helping developers be more aware of how to mitigate those attacks. I think in general, and you'll hear different views about it, but we do seem to hear more about attacks. Now, whether that means there are more of them or whether it means that they're just getting better publicised, I'm not quite sure, but I do suspect that the likes of Anonymous and the Hacktivist Collective are leading us to have a greater number of attacks in general. It's just becoming such a more accessible kind of activity, this breaking into websites.
So this point about publicity is an interesting one. We've heard in recent weeks about the likes of Sony or Twitter, both high-profile cases, and in fact Sony got fined under the Data Protection Act. Now, do you think it was right for Sony to get fined? Are we going after the wrong people?
Yeah, look, it's a good question. I mean, Sony's an interesting one because they just had such a consistent sort of series of attacks. I mean, Sony wasn't sort of one event. They had numerous flaws across multiple independent systems. It almost seemed to be a systemic problem within Sony that web security just wasn't something that was done. Now, I think also that the thing with Sony is the type of vulnerabilities that they introduced. So things like storing passwords without any cryptographic storage. I do think it's fair in this case that the ICO found them to be a little bit negligent. It's a very negligent thing for a company to handle credentials that way. And you know, one of the things we've got to remember as well, Phil, is that when we have situations like Sony where large numbers of credentials from customers are exposed, it's not just Sony that suffers. The password reuse is so high among consumers that what we see after a big breach like Sony is we see other services being breached as well. So after we had big issues with Gawker a couple of years ago, there was a lot of spam going out about acai berries on Twitter because the attackers would take the credentials from the Gawker breach and then they'd reuse them across Twitter. And It's an unfortunate thing, but I think in the case of Sony, they were right to cop a fine for that. And although it may not be a lot of money for a company that size, I think it sends a good message.
Oh, that's interesting, this issue of reusing passwords and perhaps the linking of accounts. You mentioned the Sony attack leading on to other attacks. With the rise of linking accounts, would the likes of OpenAuth or OpenID be the way to go?
Well, I think there's sort of two different sides to it there. So OpenID is as sort of a centralized authentication provider. I like the idea in terms of take the accountability away from the websites that want to implement authentication. Leave it with the likes of Twitter and Facebook, who've got enormous resources to do their security. So it sort of allows you, if you want to piggyback off the back of that, to kind of take advantage of their good work. So I like the idea of that. I guess as an aside to the security, there are logistical and usability issues that go along with that, which are to be considered. But certainly from a pure technical side of things, if you're not handling credentials, then you're a long way down the road of not having any credential problems, I guess the other side is the interdependency that we often see between accounts now. So we have so many accounts linked to other accounts. And we have seen breaches where attackers have been able to use the fact that one account has a dependency on another, and they, for example, might be able to reset one email account by using a secondary email account which they've already breached. So we are getting a lot more interdependent now, and there are risks associated with that.
Sure. So if the interdependency between accounts is to make things easier for the user and the consumer, and humans are acknowledged to be the greatest risk to internet security, how do we manage the balance between low friction and high security?
Well, it's interesting, Phil, because I think a lot of the time security is about striking a balance with usability. Many of the things that we do security-wise come at the expense of usability. Two-factor authentication, for example. Fantastic security measure. Use it wherever you can on high-value accounts, but it's a pain in the butt. You've got to wait to get an SMS or enter a token or something like that. It's not very pleasant. I guess that the problem we have is that consumers will gravitate towards the path of lowest friction. And as developers, I think our best sort of middle ground is let's implement these security measures, but we've got to do so in a low friction, because if we have people jump over hurdles, they're going to go around them and we're going to have other problems.
Of course. Troy, how about we go through the OWASP top 10 now, one at a time? Would that be okay?
Yeah, sure. Let's go through it.
Great. So let's start with number 1, injection. I'm sure many people have heard of this risk. Could you just talk us through it and then describe how you might mitigate against it?
Yeah, so number 1, and I guess keeping in mind that we're going from the most prevalent to the least prevalent here, so injection is the most prevalent risk that we have to deal with. And injection can mean injection in many different ways, but normally we think of injection as SQL injection. And injection really is where an attacker is able to change the execution of a query by sending malicious data to a web page. So for example, an attacker may change the execution of the query so that rather than selecting records from a table, it's actually dropping the table. So what we do to prevent that, we try and validate that the data coming into the system is legitimate. We try and make sure that that data can't break out of a data context and enter a query context, so we do things like parameterization. And we try and do things like make sure our database accounts are locked down. Developers very often create very liberal database accounts. They give the web application DBO. When you have DBO, you can do a lot.
Yeah, that rings a bell. I've come across that a lot of times.
It was convenient, isn't it?
Yeah, it's great. It certainly makes a developer's job a lot easier. So listen, number 2, cross-site scripting. This is where attackers add script to web pages?
Yeah, so cross-site scripting again is an extremely prevalent risk. And what's happening with cross-site scripting, it's when an attacker has an ability to submit data to a website which changes the markup of the page. So it actually changes the construction of the web page. So if we think about where you might submit a form and you submit your name, then the form says, "Thank you, Troy, for submitting this form." If I was able to add a bit of HTML after the word Troy, and I was able to add some JavaScript, maybe access some cookies, send them off through an external site, that would be a cross-site scripting risk. So like with injection, we mitigate that by making sure that the untrusted data coming into the system is validated. We also do things like implement output encoding. So output encoding is an extremely important facet around the way we prevent cross-site scripting risks. And a few other things as well, but I guess the thing with cross-site scripting is it is a very ubiquitous risk.
Okay. So injection and cross-site scripting then are ubiquitous risks. How about number 3 then? Broken authentication and session management. What's the risk here?
So it's one of those ones from OWASP that's a little bit generic. There are a few in the top 10 that are a little bit generic, and I guess the way OWASP views it is, are there risks that might allow an attacker to hijack a session? So for example, might an application persist session IDs in the URL such that if an attacker had the URL, they would be able to take over the individual session? So a very good example of how that risk looks is often session IDs are persisted in the address. Now somebody goes to a website they're interested in, they might log in, they might start filling their shopping cart, they then share that URL with a friend, and that friend suddenly has control of the original person's session and whatever else could be exposed from that session. So that's a good example of what we look at in part 3.
So that's hijacking. Great. Okay, so number 4, insecure object references. This title sounds a bit obscure.
Okay, so part 4 on insecure direct object references, what we're really talking about here is references to internal records within a system being exposed externally, an attacker manipulating those references, or often what we'd call that is parameter tampering, and gaining access to internal data. So for example, Citibank had an issue a little while ago in the UK where Citibank exposed account numbers in the URL, which in itself is probably not a good idea, but what an attacker found is that if they change that account number, and account numbers are integers, they tend to increment. So an attacker would change that account number and gain access to somebody else's account. So in essence, insecure direct object references are really about access controls. So are there proper access controls such that a user can only gain access to the records which they should have access to?
Okay, that makes sense. So even if the attacker could guess the account number, they still wouldn't get access to it. Great. Okay, so number 5 then, cross-site request forgery. This sounds a lot like cross-site scripting. So what is this one?
Yeah, so cross-site request forgery, or CSRF, is one of those ones that is quite often misunderstood. But try and think about it like this. So when you're authenticated to a website, there are certain things you can do that will be done under your identity. So you might submit a form, and when the form gets submitted, because you're authorized to do that, and we normally use things like authentication cookies to do that, the website says, okay, you're allowed to submit that form and transfer money or buy something or whatever you need to do. Now what happens with a CSRF risk is a malicious site might have a script somewhere that causes your browser to post a different request to that target site. So for example, you could go to a malicious site and the site says, make a post request to the target site and transfer money from your account into my account. So really CSRF works by exploiting the fact that the user is already logged on and the browser is being tricked into making a request. The mitigation is normally by using some sort of token, such as an anti-forgery token, to make sure that when somebody loads, say, the balances on their account, there's a little hidden ID somewhere that only that website knows and only the browser for that session knows. When they want to transfer money, that little token gets sent back and there's a validation process. So it needs to have a piece of information that the attacking site would not know.
That's great, Troy, but could I just pick you up on a point you made a moment ago about a user visiting a malicious site? Why would a user visit a malicious site when filling in personal information?
Well, it's a very good question. So first of all, it's not necessarily when they're filling in orders or personal information, it's whilst they are authenticated to the victim site. So many sites, and for example Facebook is a good one, people will log on to Facebook, they'll say remember me so that they can come back 2 weeks later, open the browser and they're still logged in. So that authenticated session actually lasts for quite a while, and that's actually one of the things we talk about in part 3 about broken authentication session management as well, minimizing that risk or that window of potential risk. So the first part is they're still logged on. The second part is we might think of it as visiting a malicious site, but the site may not originally be malicious. So a good example is there's a very popular site called Speedtest, speedtest.net. Now it was recently found that speedtest.net had been infected with malicious JavaScript. So an attacker had gained access, and they were then attempting to exploit a Java vulnerability just by putting a little bit of script in the page. So that is a site, it's a site I use, it's a site I trust, yet it had a vulnerability that obviously was now causing a malicious payload to be delivered.
Wow, that's sobering. Okay, well let's move on to number 6 then, security misconfiguration. Is this simply a case of developers not implementing authentication and authorization properly?
Well, again, it's one of those ones that's a little bit generic, Phil, and the way I look at security misconfiguration, and let's talk about it in ASP.NET because ultimately that's the course I've written. You know, one of the things that happens very commonly with security misconfiguration is developers return internal server error messages to the screen. So you will often get what you'll refer to as a yellow screen of death. So what's happening here is the web application is leaking details about the internal implementation, which an attacker might then use to exploit the web application. Another area we see that risk a lot in ASP.NET is people who are using Elmar, the error logging modules and handlers. And one thing that Elmar does very well is records very extensive diagnostic information about errors and makes it available often publicly, unless a developer has secured it. So a good example of security misconfiguration is where someone might expose these error messages externally, and they sometimes include things like passwords. They very often include things like authentication cookies, which an attacker can then take and hijack the session. So it's really just a whole range of different little configuration things that might be misconfigured in order to aid an attacker.
Yeah, that's an interesting thing about Elmar. You mentioned it on the course. Is this something that Elmar actually fixed?
Yeah, so that they have certainly fixed it, and it really wasn't so much an issue with Elmar itself. It was the guidance that the Elmar developer had given users of the system in terms of how to secure a handler. And unfortunately, the guidance on the surface of it looked logical, but in fact left it actually quite vulnerable. So I think Elmar is a fantastic tool. I use it in all my web applications, but it's one of those things you have to be very cautious of in terms of securing. And it's interesting because it's sort of that convenience versus security aspect again. I mean, we like to get easy access to error messages as developers. The security trade-off is attackers also like to get easily accessible error messages.
Of course, I understand. Just one more thing on this Elmar point. With Elmar being installed via NuGet, now that the guidance has been updated, is it simply a case of updating the package via NuGet, or do we have to go to the website and read the guidance?
Well, certainly it is on the website, so it is on Elmar's website, and that's linked in via NuGet. I guess the problem is it's not the library per se that had the vulnerability. The library's not changed. It was the configuration which was the vulnerability. So I'm not sure if via NuGet configuration alone can be updated. The other problem, of course, is that in the scheme of things, NuGet is still relatively new. I mean, we've had it, what, a couple of years? And we know that a lot of people still have implementations of libraries that are in NuGet today, but they didn't pull them from there originally. So, you know, they're not just going to be able to update it and get a magic fix.
Okay, that makes sense. So although it pays to keep your packages up to date, it isn't always the packages themselves at fault. Okay, why don't we move on to number 7 then, insecure cryptographic storage. This is about protecting credentials and data.
Yeah, this is a great one. So cryptography is really interesting. There's really two sides to cryptography which we most often deal with in ASP.NET web apps. So one side is the protection of credentials, and the other side is the encryption of things like credit cards. So credentials is the one that I personally find most interesting, and what we would normally do with credentials is we would apply a hashing algorithm. So a hashing algorithm being a one-way deterministic process where you can create a hash, but you can never uncreate a hash. So when someone logs in, we actually have to repeat the process of when they signed up and then compare these hashes together. But what's really interesting about the hashing approach is that many people are unaware of how to implement it securely, even when they think they do know. So, for example, common wisdom for many years was that we would use a salted hash, and so long as you had a salted hash, you were secure. And unfortunately what's happening now is hardware is getting so good at actually breaking hashes, so sort of consumer level hardware that you can buy for a few $100 can go through and compute billions of hashes in a second, that salted hashes alone are vulnerable, and are not just vulnerable to rainbow tables, which we always knew, but they're vulnerable to brute force attacks. So what's becoming really important now is when you use a cryptographic hash in order to store credentials, how many times are you hashing it? Are you doing it 1,000 or 5,000? Because you can't do it once or twice or even 100. So the implementation or the iterations of the hash is extremely important.
So that kind of sounds inevitable that the hashes are going to get cracked. So should our approach be to slow the attacker down and make it take them longer to get a result?
Yeah, and I think that's an important point there as well, Phil. None of this is about being unhackable, and people that talk about unhackable, are probably being a little bit too optimistic. So it's really a question of degrees, and what we're trying to do is we're trying to, and this is the case with everything we do in security, we're trying to make it hard enough that it's not going to be a risk which is commonly exploited. So in terms of things like hashes, we are increasing the duration of the process. Now, if we can make it, again, not sort of 1 or 2 or 3 times as slow, but if we can make it 1,000 times as slow for someone to crack a hash because we've hashed it over and over and over again, that's going to give us a significant advantage over just doing it once. Now, is 1,000 enough? Well, I'm sure if US government, for example, wants to break your hashes, they have ways of working far more efficiently than just 1,000 times what your garden variety hacker will. But again, it's just sort of pushing the bar. How hard can we make it without making impact on usability? So obviously, if we repeat hashes over and over again, things slow down. So how slow is fast enough for someone to log on?
So that comes back to that earlier point about friction, doesn't it?
Yeah, exactly. It's just it's a trade-off the whole time.
Sure. Okay then. Number 8, failure to restrict URL access. The title doesn't seem immediately obvious.
Yeah, when you think about it, it's not a particularly hard one either. So really what we're saying is, hey, there's a URL that is not meant to be accessible by certain parties, and often those certain parties are the public, but they are. So it's a little bit like insecure direct object references, but rather than sort of enumerating parameters and trying to get access to different IDs, it's things like, do you have admin paths that actually have access controls on them? And believe it or not, many times they don't. So for example, developers will say, well look, I'll be a little bit tricky and I will name my path something that people will not know. And unfortunately that's a bit of a risky proposition. Or the other thing we often find is there are access controls colloquially maybe on the door but not on the window. So maybe there are access controls so that we only get an admin link if you're logged in as an admin, but then the resource that that links through to isn't protected, so people can always sort of go around the side.
So the developers are just relying on obfuscation. You can't see the link, so you can't follow it.
Yeah, I think there's certainly a bit of security through obscurity going on there.
Cool. Okay, number 9, insufficient transport layer protection. This kind of sounds like we're leaving it up to IT pros to manage SSL and the like.
Yeah, that's an interesting one. So, a lot of these items in the top 10, Phil, that they're not absolutes. And in fact, most of the things with security are not absolutes. So with transport layer protection, it's not a matter about do you or don't you have it. It's a matter of, is it sufficient? Has it been implemented sufficiently well? So many people would look at a website and say, well, look, when I log on, are my credentials sent over an HTTPS connection? Yes, okay, that's enough. It's not really enough, though. So, for example, are we actually loading logon forms over HTTPS? Because if we're not, then they are subject to manipulation in transit. So we've seen examples, and there's a very good example from Tunisia when they have a bunch of social uprising recently, where the government-controlled ISPs were injecting script into the logon forms so that when someone logged in, they would have their credentials harvested and sent off to the government. So that's a good example. Also things like when you do log on and you authenticate and you have an authentication token which exists in your cookies, is that authentication token protected? So a few years ago we had Firesheep, where what a developer did is he said, look, I can build a plugin for Firefox so that if you go and sit in an internet cafe and you get on the Wi-Fi and there are other people browsing around and they're using Facebook and their authentication token is not being sent over a secure connection, we're going to sniff that and steal it and hijack the session. So HTTPS and transport layer security goes well beyond just protecting credentials at logon, and that's why this risk talks about insufficient protection.
I see. Okay, so let's turn to number 10 then, unvalidated requests and forwards. So what harm can these do to a site?
Well, to be honest, I always find that number 10 is a little bit anticlimactic. And it's anticlimactic because it's not a very glamorous risk, and it's also a risk that some companies don't actually believe is really worthy of being categorized as a risk. So an unvalidated redirect, or what's often called an open redirect, is where you commonly see this pattern where you look at the URL and the URL has a query string, and in that query string is another URL. So for example, many sites have a "you are leaving this site, we cannot be responsible for what happens after here" sort of warning. And developers, in order to try and reuse code, will say, okay, well look, I'm going to have one page, which is like our exit page with the warning, and the way I'm going to reuse that is I'm going to link all of these other pages into there, and I'm going to pass this parameter which says after you accept the risk, then you go on to that URL. Now the risk in terms of what an attacker can do with it is they can use that as a bit of a launch pad into another attack. So for example, if I sent you a URL that was a site that you trusted, so say it was hsbc.co.uk as an example, and they had an open redirect risk, you might look at the domain of a long URL I send you and go, okay, well that's HSBC, I trust those guys, but what's actually embedded after that in the open redirect is a link off to a malicious site. And if HSBC had an open redirect risk, you'd open that link and you would possibly then end up somewhere totally different, thinking you were going to be somewhere quite safe.
Oh, okay. So this isn't something that can harm the HSBC site. This is more of a business impact in that they're going to lose the trust of the users.
Yes, so it wouldn't harm them insofar as it's not exploiting any data on their site, but it is using them as a launch pad which could impact trust. So if I was to have an HSBC link and I click on it and it has an open redirect through to malware, you know, as a consumer, I'm looking at this saying, hey, I clicked on a link to HSBC and you guys gave me malware. Well, they didn't, but they facilitated it.
Okay, so that's a lack of trust all around then.
Correct. And, you know, when I said some people don't take it too seriously as well, one of the interesting things there is Google doesn't pay bug bounties for open redirects. You know, they'll pay bug bounties for serious things like injection and cross-site scripting, but open redirects, yeah, not so much.
And so bug bounties, this is where users discover risks, report them and get rewarded.
Yeah, so a number of companies like Google or Facebook have bounties where if you manage to find a vulnerability, and it has to fit into a certain classification, but you know, you find a risk and they'll pay money. PayPal's another one that does that. Now that's assuming you ethically disclose it and you don't just go and use it to steal people's credit cards.
Absolutely. Well, okay, other than the top 10, are there any other significant risks we should be aware of?
Yeah, well, look, you know, one of the things I always say is don't stop at the top 10. It's not exhaustive, it's just the 10 most common risks. So a couple that come to mind, clickjacking is very popular. So you often see clickjacking attacks on Facebook where you'll have a link to a web page and it'll be a page external to Facebook, and you'll see something that's enticing on the page. So one that goes around a lot is there'll be a sort of salacious girl there and a play button, you know, click on the play button and watch this, you know, enticing video. And what actually happens is that is overlaid, or rather it sits under a transparent or hidden like button for Facebook. So what you're actually doing is you're clicking a like button on Facebook, so it's, you know, hijacking your click, hence clickjacking. So that's one. Mass assignment vulnerabilities as well. So recently there are some pretty serious risks in other frameworks around mass assignment where in these sort of MVC patterns where we're able to sort of serialize and submit an object in a post request and then whatever framework you're using will receive that and sort of rehydrate the object and save it. One of the risks that happens with mass assignment is, you know, I might have an entity which is, you know, my sort of personal profile, and I go in there and I edit my name and I edit my email address. But behind that in the database, I might also have a flag called, you know, is Troy an admin? And the mass assignment risk happens when an attacker says, well, look, I'm just going to send this piece of data as well. I'm going to send them a piece of data that says, yes, I'm an admin. Now, if the framework uses this sort of very generic pattern where it says, look, just get all the attributes that are posted and see if I can match them back up to this internal entity, you know, then there's a risk there that someone could actually go through and change other attributes that they're not intended to. So that doesn't really fit very well into any of the top 10, but certainly it has been a serious risk for frameworks like Ruby on Rails.
Wow, so the attacker can simply add fields to a form that weren't revealed to begin with. Well, how would the attacker know of the existence of these fields in the database? Have they used any other form of attack to reveal it?
Well, I mean, guesswork is certainly one way of doing it. Another way is that many frameworks and products these days are open sourced, so they may have access to what's in there already. Many of these products are on GitHub. They may also exploit, say, a security misconfiguration risk. So there might be an error message somewhere that is disclosing the internal structure. There might be a SQL injection risk, which allows you to enumerate through tables and columns within the database. So there are lots of different ways for an attacker to gain enough information to then go through and exploit another risk.
Right, so all the more reason to implement the top 10 in addition to everything else.
Yeah, and this is the thing as well. It's very frequently not just one clear vulnerability that's exploited. It might be one that leads to another that leads to another, and these things sort of cascade a little bit.
Sure, that makes sense. Troy, you talk about the top 10 and list one mitigation after another. Here's another feature you can add to your app to make it more secure. Do you get the feeling that developers just see security as an add-on feature?
I think often it's not a conscious thing. And look, the analogy that I often give, Phil, is I think it's very much like web application performance. Okay, so you will go to a lot of websites and you look at it and you go, why has this guy got a 500 kilobyte background image? Did he really need to do that? Is he actually aware of it? There's not a business requirement or a line item that says don't put a 500 kilobyte background image on there, any more than there is going to be a business requirement which says don't have a SQL injection risk on my app. And I think a lot of what this comes down to is, do developers have the competencies to understand fundamental things like application performance and like security? Now, of course, if your background image is too big, then it just takes a little bit longer to download. If you've got SQL injection, then your customer database is out there. So it's probably not an entirely fair analogy, but I think it's similar insofar as it's not necessarily something that developers, A, have expertise in, and B, actually invest time in verifying during the build process.
Sure, understood. Well, would it be worth making these security features standard technical requirements in addition to any other requirements for the project itself?
Yeah, look, I think it's a combination of things. So certainly most software development environments, whether that be a dedicated sort of software development house or whether it be an IT department within a larger enterprise, normally there is some sort of set of standards. So for me, for example, I would always make sure the OWASP top 10 is in there, and I'll say, guys, you've got to go through, read this, understand it, manually test for it. So I think it needs to be socialized into the process. It does get a little bit difficult sort of on a project-by-project basis to say, look, I'm going to have technical requirements that talk explicitly about individual mitigations. I like to try and take something that's sort of more of an open standard and include that with the projects that I get involved in.
Okay, that's fine. So it's more of a cultural and open standards approach. Well, let me ask you just a couple more questions. So the course you've just written for QA and the book that you wrote also, OWASP Top 10 for .NET Developers, you mentioned earlier that OWASP is technology agnostic. Is there any guidance out there for Java developers, for example?
Are you guys doing something on Java?
Yeah, well, that's why I asked.
Well, look, I like to think, I think the material that I've written on my blog, including the book and also the material I've written for you guys, I think it's actually a pretty good mix of very generic industry practices and specific implementations within a framework. So I think you could take a PHP developer or a Java developer, sit down and go through and do the OWASP Top 10 for .NET, which you guys are running, and you'd get a lot out of it. Now, the bit that misses off the back end of that, if you like, is now that I understand how SQL injection works, or now that I understand how cross-site scripting works, and in the demos in the course, you're doing this as an attacker from a browser. The way you experience it is having access to what they would have access to, which is web browsers and HTTP. I think developers and other frameworks would take a lot away from that, and then they need to go, okay, now that I understand how this works, how do I implement the mitigations in my chosen framework?
Okay. Well, listen, one last question. The current OWASP Top 10 is for 2010. So when is the next revision?
So the top 10 for 2010 superseded the top 10 for 2007. And when it did supersede 2007, there were only a couple of things that changed. And some of them were sort of changes in definition more than being totally new risks. My understanding is that there is going to be a 2013 edition. I'm not quite sure how much that's going to change. I don't think it's going to be anything radical. The other thing that I know OWASP are working on is a mobile apps risk. So obviously mobile is very big now. The top 10 is such a good guide for web applications. It would be great to have one for mobile apps as well. So I think, possibly a 2013 version of top 10 and the mobile one is what to look out for this year.
Yes, of course, that's something to look out for. All this talk about web apps, we didn't even consider mobile.
Well, I mean, OWASP is the Open Web Application Security Project, but the lines get a little bit blurred now, don't they, Phil? I mean, okay, you have native mobile apps, but it's pretty rare to have a native mobile app that doesn't have some sort of internet connectivity. And then a lot of the time, those mobile apps are, built in something like PhoneGate or Titanium, and they're HTML and JavaScript underneath anyway. So, it's a pretty ubiquitous technology now.
Of course, of course. Listen, Troy, I've taken up enough of your time. Thank you so much for talking to me today. I really appreciate it, and thanks for such a brilliant course.
Yeah, thanks, Phil, and I had a lot of fun building the course, so I hope it's of really good benefit to people.
Absolutely, it's a great course. It spells out all the risks and how to mitigate against them. They'll certainly appreciate the content. Thanks again, Troy.